Recording in progress.
Hey, Professor.
Hey, wow, what's the lighting here?
Oh, I also have to turn on my light.
No, it's on my side. You're good.
Oh,
Nice.
my room is a little bit dark also. Let me turn on the light.
I'm gonna throw the curtain here. Maybe that'll help. Wow, made a
There it
huge
is.
difference. Oh, wow, that is so cool. Okay, awesome. I'm glad you could make this meeting. Because I saw that demo and I thought this is so much scope for doing some really cool shit there. Yes.
Yeah.
And I think you can turn it to make something really impressive there. So let's not waste time. Actually.
Okay.
If you can share your screen, there's something we did in CS2A last quarter. Not even this quarter. No, last quarter we did something really cool. So let's go to the blue subreddit. And search for
The blue subreddit is
CS2A, CS2A.
Oh, 2A.
Yeah. Just go to oh wow, it just does that. Okay.
Yeah.
And then you can search in the subreddit for you won't find it here for Totoro, Totoro.
Totoro? Oh, like the anime.
The Miyazaki. Yeah. All right. So 3 months ago, you click that. Click that one. All right. Hang on. No, not this one. Okay, go back. One more. Yeah. That one. The second one.
Right.
Yeah. Okay. Great. Okay. All right. So I remembered this. Okay. Now, this is very similar to what you're doing. In fact, this whole project in CS2A started off after you and I and Adam had that experiment in Docker. You remember last quarter?
Yeah.
And then we did say, let's try some ANSI codes and see if we can position those things.
Yeah.
And then I thought, well, you know what? Why don't we use that in my CS2A class? And so this is what we did. Okay. So in fact, you can see, click that. You can run it on online GDB too. Yeah, you can just run it there too.
Yeah, that's true.
Okay. Yeah, this is, one of our students, one of the CS2A students, Erica, made this movie, but she made it in code. Okay. She made it in code, just like you did the cube rotation in code. Yeah. So what we did in class was this, which said you don't have to that's right. You don't have to generate the whole thing in code. Okay. Click on totoro.txt.
Click on which one?
The tab next to main.cpp.
Oh, totoro.txt.
There you go. Okay. So if you look at this frame, if you look at this file, it's a text file. It's a .txt file, right? It's a text file. And if you look at it, all it has is basically a bunch of frames out there. Right.
Yeah.
And because it's a text file, it can be compressed like a huge deal, especially since there are lots of repeating lines. And also the cool thing is that you don't have to encode the whole frame because you only have to encode up to the last visible character. You can omit all the blank spaces after that.
Right.
Right. So a whole movie in this format could actually be compressed really well into a zip file. And someone just has to unzip the file onto the terminal and they'll see the animation. Yes. Now, however, with what you're doing, and because we were talking about this the other day, I thought, well, you know what? You're not going to supply a binary and say, hey, compile this program and run this program and this particular architecture on a Docker. That's not what you want to do, right? That's not geeky enough. Right? What we want to do is basically just give them a text file. So it doesn't matter what operating system you're on. If it's ANSI compliant, which goes all the way back to MS-DOS, Microsoft DOS, right? IBM DOS. So if your terminal is ANSI compliant, it'll work, right? Because it's just a text file. And so that's a cool thing. That's what we want to do. So what we want to do, however, is some parts like the cube generation and all, that absolutely needs to be done in code like you've done, because there's some sophisticated mathematics going on there, right? And so you need those loops. Okay. However, that could be one scene in a 5-scene movie, right? Maybe that's scene number 1. And,
Yeah.
and scene number 0, maybe that's scene number 2. And scene number 0 is probably some animation of Chris Kusmona's, I don't know, Tesseract, because it actually does look like a Tesseract, right?
It
Rather than a
does.
cube, for 4-dimensional or 5-dimensional cube, because of all the intersecting faces.
Yeah, I feel like it's because of the rendering still buggy.
But it's really cool. Yeah, don't change it because it's really cool.
Okay.
So you can have your movie could be called Chris Kusmana's Tesseract, right?
Right.
Or Dancing Tesseract or something like that. And then that could basically be, I don't know, 100 frames. Okay, when I say 100 frames, what I mean is that you have one frame repeating 50 times, another frame repeating 50 times. So you have an animation there. So let's say it's 500 frames. Okay, so you have 5 frames. Okay, each frame repeating 50 times. So the cat program, when you dump it to the screen, it's not going to do any computation. It's going to keep dumping the frames one after another. But the time it'll take to dump 50 of exactly the same frames will be enough to cause the sleep-like delay for us.
Oh, got it.
Yeah, but I thought some changes to make that happen I can discuss with you today, and I think it'll just be a couple of days for you, or less than that, even to pull them all together, to give form to this idea, which I think will make a really, really cool post. All right, so there's going to be a bunch of programs here now. So let's go to a text editor. So do you understand what they did? You can also look at the code later, right?
Yeah.
In fact, you can borrow a lot of this code, because even though you'll be able to write it, sometimes you can just copy and paste, right? It's faster because if you understand these things, right? So you can borrow a lot of this code for doing the frames, and you can make it more efficient in the process, because I think that when we were reading in the vector of length per frame, we were not ignoring the trailing spaces. Right, you don't have to read in the trailing spaces, right? And when you save these files too, you don't have to read, right? So let's go to open up a terminal now. Open up your own terminal. Let's go to an editor, and then we'll start playing around in the editor. So far that's okay, right?
Yeah, that's fine.
Great. Okay. So I'm thinking of 2 things, and then we'll refine the idea as remind me when it's like 10 minutes to 6 or something, okay? Because there's a CS2 meeting at 6 o'clock.
Yeah.
Right. Hopefully we won't go that far, that long. What was I saying? Yeah. Okay. So the way I'm thinking about it right now, and it could evolve, is that first we want to create a program that can read in a bunch of frames and spit out the decoded frames. Meaning, what I mean by that is that now open, let's say open, make a directory called, Tesseract, right? Tesseract. Make a directory, because it's going to be a movie, right? Now change into this directory.
Change into the.
Make there. No, you got to make there. Tesseract, and then cd test and tab. Right. So all right. So here you are. So let's say we want to create a file now. Let's say we call it so edit a file, create a file called scene-01
space dash 0.
No space. It's the name of the file. Scene-01 dot input, right? Dot. You can call it different things later. Okay, we're just doing stopgap values for these names. Okay, you can change all these things later. Okay. You don't have to call it dot input. You can call it something else later. So edit this file. Do you know how to use Vim or Emacs or something like this on the terminal? I can show you.
Oh, the Vim? No, I have never used Vim before.
Yeah, all right. How about actually type Emacs and hit return? I think you may like Emacs.
This?
Emacs. Oh, I see. This is a Docker thing. So after you exit, the disk will be wiped and all? Or do you have it saved elsewhere? Your Docker
It says
image.
command not found. I can make a new Docker image. I mean, this will save.
Oh, you can make a new Docker image. Okay, let's make an image now. You can save it. So I mean, we're going to play around with this, and you can save the image later. Yeah.
Yeah.
I think. Yeah. All right. So do yum install Emacs. I don't know. You may have to sudo it, right? You don't have yum. apt get.
Yeah, I think it's apt.
Yeah, you need to sudo it.
apt-get Emacs. I think it's
I
sudo by
think apt-get
default.
install, apt-get,
T-get.
and you need to sudo it first. You need to sudo. Oh, you don't have sudo. You're not root on this machine. You are root. You're
I am.
okay. All
Yeah,
right,
I'm
okay.
already. It's
Yeah.
already default sudo.
Okay. Apt-get install Emacs. Apt-get install Emacs.
Is that how you type Emacs? Because it
No,
says
no, Emacs. That's correct. Yeah, just type install Emacs in front.
Emacs. Ah, there it is.
All right. So yeah, hit Y, hit Y. I got this really cool text editor now. It's called Emacs, and it was originally written by the Richard Stallman. He was at MIT, and it's a very nice editor in many ways. It's if you know Lisp, you can customize it. VI also you can customize endlessly, right? And like VS Code and all. But Emacs got so popular that all of the other editors started to give an Emacs mode. So even if you're an Xcode or VS Code, anywhere you go, even VI has an Emacs mode in it, I think, right? Because people like to type. And what I like about Emacs is that it just minimizes the amount of muscle movement in your fingers, right? For example, you can have your pinky down on the control key, and then you can do a lot of stuff. Just with that one finger on the control key. So, and it kind of works nicely. Well, I've known people who do that in VI also, but Emacs. Wow. Maybe is it slow? This is the longest it's taken to install Emacs in my.
Oh, I think it's because the apt needed update. I updated it. I just updated it.
Oh, I see.
Yeah.
All right. Well, you can open another terminal. We'll play around in VI until this thing. Open. Yeah. All right. So go into the directory. Did you get the same directory here?
Let me see. No, I don't.
So, it's not mounting the same disk.
Yeah.
Yeah.
It's
Okay.
not.
Just go in here.
I think I have to.
Oh,
I have to make.
later on when you do the image, you can do it.
I think I have to make the
go in there.
directory.
No, go in there. Go in there.
Oh.
We'll just play around here, and we will use VI for now. Yeah, make your Tesseract. Go into Tesseract, and then use VI.
No.
You can just directly do VI. It'll create it for you. VI. First hit enter. We'll see if you have VI. Vim, VIM.
Oh, Vim.
How come you don't have any editors?
Not sure.
What kind of editor do you have on this machine?
I use VS Code, but then
on this machine on your Docker.
Oh no, I don't have any editor in Docker.
Okay,
I use VS Code.
Some editor installed. There is an editor. Ed. It's a pain to use. So just type VI and hit enter. Tab. Hit VI and tab. Okay, VI tab. No, not Vim. VI and tab. Tab. Oh. What about etab? Nano? I don't know. Nano? Yeah, just nano.
Nothing happened. So
it is a very basic minimal shell.
Yeah.
Which shell? So next time you create an image, use a good Ubuntu distribution. Many of them have these basic commands built in, and they're very thin. Especially since you have less space and all on your disk.
I could do Docker run at Ubuntu, I guess. Yeah.
All right, let's go to any other terminal that you have an editor for. It doesn't have to be, we don't have to be in Docker. Just, you can just go to your Windows and just get into an editor. Even, Microsoft Word is fine.
Right. Yeah, we can do VS Code, I guess.
Yeah, okay. Just create a brand new file. Right, and call it what was it? Yeah, scene --1 scene-01
input?
input.txt. Let's always end all the all of them with .txt, so people know that there are no binaries anywhere here. Okay. All right. So here's what I'm thinking of. Okay. Is it going to be a meta line? Do you know about recursive distance parsing? Have you read up? Do you have an introduction to compiler theory and how compilers work?
No, I have not.
Oh, okay. Do you have you played around with parsing text before? Parsing according to a grammar?
No.
Oh, all right. So, all right. Okay. So these are fantastic skills to have. We actually teach them in graduate level compiler theory courses, but they're actually very simple and fun. I'm pretty sure you'll understand it too. If you guys are interested, if you and maybe other people too, I can give you a short, 1 or 2 lecture intro to a very basic parsing technique called recursive descent parsing. Now, recursive descent parsing, you can come up with a language of your own, and then you can write a parser for it instantly, right? And it's so easy because you know about recursion, right? And you know how did I write a recursive descent parser, especially since you know C++ and all. So you can take a file written in a language that you have described or invented, right? And this program will be able to read that file and generate whatever you want, machine instructions, or in a different language, maybe from language A to language B, because you'd be able to parse it and translate it. It's a very powerful skill to have, even in business settings, because sometimes you want to transform data from one form to another. Yes.
Yeah.
In order to make it suitable for some kind of machine learning input. So you may say that, well, the data is in this form, but in order to transform that, it's not a regular transformation. It needs to go to a grammatical change. And so you can define a grammar that will transform this data from here to there, and you can write a parser will take it and transform it too, right? So there's lots of things you can do that cannot be straightforward transformations if you can do these parsing techniques. So I'm happy to teach you these things. We will do another Zoom session, maybe not today, right? But here's what I'm thinking of. And so I'm just going to dive into the language itself. It's such a simple language, okay? And it's going to be super easy to implement it using recursive descent parsing. You won't even know you're doing recursive descent parsing. You'll be doing this, right? So now type hash. No, hash, the hash mark.
Like the actual hash.
Hash mark. Okay, let's just say that everything that starts with a hash is going to be special to your, the program that a.out you're going to write, which will read this file and generate frames for you.
Okay.
Right. Those frames, once generated, can just be sent to the output, meaning that if you take the frames, generate the frames, and you send it to the screen, you get the animation. Instead of sending to the screen, you can just take the frames and stick it into a file, and then you can cat the file later. Yeah.
Right.
Okay, cool. So that's a program which you already have, that Tesseract, that thing you've done. We're just going to write a simpler version of it, which is going to take this frame input file and decode what you have in there into a bunch of frames that'll spit out on the output. That's all. Okay, that's exactly what Totoro does. So Totoro, she's got a bunch of, I don't know, 20 frames or so. Yeah. And each frame is a different stage in the animation. That's all. And then the program she wrote basically reads the text file and then displays the first frame, sleeps for n milliseconds, then sets cursor back to the top, displays the second frame, sleeps for n milliseconds, and does that until all the frames are exhausted. That's all it does. Right? However, it doesn't have that sophisticated hook that we're trying to put in there, which is to turn that a little more into a language. Okay, so here is what we're going to say. We're going to say hash space frame. Frame. You can keep it, case insensitive, right? It doesn't matter which frame. We can when you parse this file, you can say it doesn't matter what case it is. Yeah. Okay. So frame hash space frame, and then say x times, basically times, right? Times. No, just x is 1x. No, space x. I'm so sorry. Or you can say times. Yeah, say star, right? Star. All right, frame, and say 50 times, right? 50 times. 50, right? Okay. All right. So now, and then on the next line, you can say hash, right? And then now you can say comment. Okay. Now space. Now you can say the next set of lines defines we can say the next 50 lines, or let's say the next 10 lines. The next 10 lines will comprise our first frame, which will be repeated 50 times by the program. Yeah, that's all. Okay, right, so just write it out. Yeah, you can say the next 10 lines will make up our frame. Repeat it 50 times in the output. You can put that in parentheses. Repeat it 50 times. That's all. Okay.
Right.
And now what we can do is in the first frame, maybe you're going to say, yeah, right. Yeah, let's do that. Okay. Maybe the first line is blank. Okay. So go to the next line. Right. You put a bunch of blank lines. Enter,
Blank.
enter. No, not blank spaces. Enter, enter, enter.
Oh.
Yeah. Okay. Now, all right. So go to your browser. Go to yeah. Open a tab and Google for ASCII art. I don't know. Maybe we'll call ASCII art. ASCII ASCII art. Yeah, ASCII art archive. Yeah. All right. So grab something interesting from here and put it there. Okay. Maybe food and drinks. Oh yeah. Maybe I don't know.
Let's see. Can do fish.
Yeah, okay. So grab one of these, put it there. Put it there.
This sounds nice.
Yeah, okay, cool. Right, and put it.
I like the whale. Never mind.
Okay. All right. Okay. Now put it in your file. All right. Blank line. Blank line again. Offset the whale to the middle of the screen. Okay, not the total middle. Assuming your frame is going to be like that wide. Yeah, right. Offset. Put some tabs in front of. Yeah. There you go. Okay, cool. Right. Now you can say Tesseract. Right, in all uppercase with one letter, one space between them. TESSE.
Which line do I put it in?
Oh, just some. Imagine this is going to be a frame, like a movie, right? You can center it and play around with special effects. Later on, you can change the frame completely, right? Maybe you're going to have a whale, right? Tesseract, Tesseract, and on the next line, you can say by Chris Kusmana, right? 2023. 2023 is in parentheses, like references. Okay, all right. Now, here is the cool thing. Now, what we can do is, what I'm thinking here is that if you just had this, this is your frame, right? And if you made an A.out that is going to spit out the frames from this, it's just going to spit out this. It's going to set the cursor to some location, and it's going to spit this frame out 50 times. Yeah, right. So there's no animation, right? The same frame is drawn 50 times.
Yeah.
So we want another frame after this. So now copy the whole thing, put it right. Whole thing, including hash frame times 50. Yeah, put it there. And next line. Okay. Now offset the whale to the I don't know, to do some animation, right? Change the positions.
Like you just make it farther.
Yeah, okay. Yeah, and Tesseract, maybe move the Tesseract on this side. Yeah, and so on. Okay. Yeah, okay, cool. Yeah, you change Chris, offset Chris Kusmana also.
Moving with the whale.
Yeah, okay. All right, yeah, but you can play around with this later. We're just trying to do something here really quick, quickly, just to get an idea. All right. So now what will this happen? What will this do? It'll print out the first frame 50 times, and then it'll print out the second frame 50 times, right? Now, the number 50 you can play around with later on, right? In fact, you can even make that a parameter that's passed into your frame generator. Right. Yeah, you can do all those things later on. We'll just use the hard-coded number 50 for now.
Yeah.
All right.
The number 50 would be like the one that's giving the time.sleep effect, right?
Yes.
That's determined
because in the cat you won't get to sleep.
Right.
Yeah, exactly. That's so. But what I was thinking was it would be nice later on to not just repeat a single frame, but to have the ability to repeat a sequence of frames. So you can do a dance step, which is an animation, and you can do the dance step itself 5 times. Right. So let's not mess around with that idea now. So right now, let's just restrict our attention to just one frame, repeating one frame. Okay. Now, obviously, now you can think about doing the title. That scene 1 is your title. Okay.
Yeah.
The title is going to come out from something like this. A text file that's going to be generated from this input. Okay, and you can have many frames, 50, maybe you're going to have, I don't know, you can play around with this. You get the idea, right?
Yeah.
All right, so now what we'll do is write a really short program that can take this and turn it into and spit it out. In fact, what we'll do is let's see if we can salvage anything out of the. Can you X that panel because it's taking up some real estate? You got a message there. Yeah, that one. Just
this one. What do I,
There's an X. I see an X on the right.
Oh, this one. Okay, got it.
Yeah. All right. Okay, great. So let's grab that thing from CS2A, and we'll see if we can if there's anything we can salvage from there.
This one, right?
Yeah. Just copy the whole thing. It's not a big thing. It's a really small. Yeah, copy that into a file. Let's actually go through the file. I'll try and remember what the hell it does.
Yeah, let's see.
Let's call it. No. I don't call it main.cpp. Call it. Oh, you don't have another main? Do you have another main here in this directory? Oh, you have a cube and all.
Yeah.
So you need to call this. Let's say, what does it do? It reads the frame input file and generates.
Like a parser?
No, it's not parsing. Parsing is not the center of this. So we should call it. What is your movie making technique? You got to come up with a name for this movie making technique. Frame animator. I don't know, whatever. Let's call it, for now, tentatively, let's call it frame input to output. Frame input to output. You call it later, change the name later on, okay? Frame IO, or I know that sounds like it's a binary already. What we should say is frame generator. Just call it frame generator. Call frame gen. Yeah, all right, for now. Okay, change it later.
Okay.
All right, now copy, paste the whole thing that you had. Now let's go to our main here. Okay, what does it do in main?
I'm seeing error.
Right at the bottom. The last one, very last function is main. Okay.
Oh, this one.
Can you increase the font size just a little bit? Yeah. Did it increase? Yeah. Okay, great. Oh, that's great. It's got a vector of a frame. Now, what is a frame? What's a frame class? Can we take a quick look at the frame class? What the hell does it do?
This is frame class. So it has the constant. Okay, vector string of data.
So it's got a set pixel, it's got a clear pixel, and it's got a write string add. I see. And what does append do? Show frame add, show frame sequence add. Oh, I see. That's how it does it. Okay. So we have a show frame add here and clear frame add.
Mm-hmm.
I see. And read frames from file. That's what I was looking for. Yeah, there you go. Read frames. Yeah, that's the function we want to look at.
This function here, I think.
Okay, what does it do? All right, so it opens a file. And I see what we did. So in CS2A, we didn't use a hash because we weren't doing parsing and all. We just said anything less than 20 characters, we'll just ignore. So we were using hash frame as a comment because it was less than 20 characters. So we make sure that every line has to be at least 20 characters. So that's what we did. But you can do it slightly differently. So while it's getting the lines, min length, right? Oh, I see. Okay, if it's a new, if it's less than min length, we start a new frame, and our frame.data.size greater than 0 reads a frame. I see. Oh, that's all it does. Okay, right. So essentially, it's reading all the lines when it encounters. So what we need to do is we basically need to modify this. I'm not gonna. Unless you want me to, I won't walk you through it. I'll tell you the idea, and then you can do it and let me know when you're done. We can reconvene. Maybe today, maybe tomorrow, whenever. Yeah, is that okay with you?
Yeah, I think I'll do my own research about it, and then if I get stuff, I can ask you about it.
I think that's much better. Okay, so you can take a look at this. And so what we want to do is essentially in your main program, in your frame gen, all it's going to do is open this file that you've created with scene1 input.txt.
Yeah.
It's going to open that. And if it sees a line that begins with, gee, bummer. Yeah. That's why we didn't use a hash. Because a hash could be part of a scene, right? You can have a hash inside you can have a scene that,
that begins
I think, how about this, okay? Let's see that, let's make sure, even here, you can just assume that every line has got to be minimum, I don't know, 50 characters, okay? Because I don't think you're going to have an animation. Maybe you'll have an animation less than that. Pick some minimum length. Okay. Anything less than that, you're going to assume is going to be a command to your program, not a frame. So the file has two kinds of lines. One is a command to your program or a comment, which will be ignored. Anything that's longer than that length is going to be part of a frame, part of the next frame that you'll read into a vector. Okay. All right. So now, assuming that it's 50 characters, you'll see if it's less than 50 characters, take the first word. Okay. If the first word is a frame and the second word is an X, two separate words. And the third word is a number. It's got to be a number.
Right.
Okay. Then you know what to do, right?
Yeah.
All you need to do is read the frame and then spit it out without a sleep.
50 times.
That many times.
I mean, X amount of times.
X amount of times. No. X is that character we're using, or maybe use a star.
Oh, yeah. Number.
Yeah. I know what you mean.
After the X.
All right. Now that part can get more and more complex. You can have conditionals, and later on, that's when the recursive descent parsing will become useful. And if people are interested, I'm happy to show you how it works, and I'll also get you guys to implement a recursive descent parser. We'll just take a couple of lectures, okay, like this.
Okay.
But it'll have to be like a 2-hour lecture, not like this hurried thing that we're doing now. Okay? Just talk with your classmates and let me know. Anyone who's done Quest 9, right? Anyone who's done Quest 9 and wants to learn about compiler theory and at least recursive descent parsing, right? I'll get all of you to implement a recursive descent parser by the end of day 2, right? The lecture 2, and for a simple language that we'll design. Right?
Okay.
So that's separate. But for now, you don't have to do a recursive descent parser and all. There's only 3 things you need to check for. If it's less than 50 characters, if it's less than 50 characters, what's the first word? What's the second word? What's the third word? If it doesn't have 3 words, all you can do is just say syntax error in line number 75, right? You got something that's less than 50 characters and it doesn't have 3 parameters. However, if it only has 1 parameter, hash frame, or you just say frame, right?
Yeah, hash frame.
Yeah, hash frame as a single word, maybe that sets it apart mentally, I think, easily. I don't know, you can decide these things later on. If it only has 1 word, frame, you can say you can assign default values for the next 2 guys. If it's a frame, just the word frame, it means if it only you're actually taking notes. Yeah, okay, cool. So if it has assign default values for the next 2 parameters. Yeah, just say it's one time, it's times 1.
Right, like a default value.
Something like that. Just put yourself in the shoes of the user who's going to be using your program, and you'll come up with all these ideas. And say, well, do they want to would users find? But the thing is, don't go overboard, because it'll be very tempting saying, well, there's this XYZ user in Timbuktu who may need this, so I'm going to implement that. So that's the rabbit hole that programmers shouldn't go down to. Newbies always find it very tempting to say, I want to design for every possible use case. Some remote user, I want to account for them. That means the product never gets released. So you got to draw the line somewhere. Yeah. So if you're in doubt, always ask me, and I can say, well, it's nice to have, but it's not essential. So you need to get to the proof of concept first. So don't do all that. So get some simple things done, and when you have this ready, so you already have a good idea of what's going to happen, right? You're going to do the title scene 01, which is going to be like at least 10 seconds, okay, or maybe 5 seconds. And you have to have some neat animation. What we did some, lame ass stuff there was with the whale. That's all simple. You play around with the title thing. Oh, the only thing is you're not going to have any music, okay? But other than that, you can have a lot of stuff. You can even have speech bubbles. You can have a function that adds a speech bubble, right? So you can have a stick man, and then a speech bubble, grow out of, in the atmosphere, the air, right? And then you can have text in there, and all of that could be animated too. And that could be, that could be a function. So not all of that needs to be part of this, because your cube is going to be generating frames too, but it's not this, right?
Yeah.
So essentially what you're going to do is scene 01 is going to be generated by your new a.out, which will read by framegen.cpp, which reads scene 01 input.txt. Scene 02 will be generated by your cube.exe.
Okay.
All right. So eventually, what will happen is this is being recorded. Good. Okay. Eventually, what will happen is that you will end up with a directory. Okay, a directory in which you will have many files. Scene 01, Scene 02, Scene 03, Scene 04, Scene 05. Each one maybe 5 seconds. So this entire movie, which is made up of n scenes, right? And each scene would be XYZ seconds long. And so essentially, someone could basically say, cat star all of the files in this directory, and they have all the scenes automatically playing after each other one by one.
Making an ASCII movie.
Really cool. And the first one, the frame zone stuff is easy because people, even non-mathematicians and not computer scientists can do this because all they need is a text editor and they can just do the individual frames. Yes.
Yeah.
And then use your program to generate the actual movie. However, the second part that you did with the Tesseract, which is really cool, that really needs computer science knowledge, right? So you're going to make a movie with the title scene generated using this, and then the Tesseract, make it play for a longer time, I don't know, and maybe even have some text jumping around while the cube is rotating, all of that, right? And then you can have the ending credits too.
Right.
Right. So and you can and in fact I can cat star and into whole movie.txt, and that's also possible. Yeah. So it opens up many possibilities, and this program itself might be a new kind of entertainment, because when you get to really think about it, when we get to reality level simulation in our headsets and all, yeah, because today you can imagine anything and you can give that instant actualization in your head, right? We're using these devices. So now people will start to get bored with reality and will say, well, I want to try and do some lame as ancient floppy disk kind of simulations and see, interesting movies done that way, right? So that could be an entirely new fad. And I'd be fun. I think it'll be fun. But I will look forward to looking at this movie. And I thought this would be a really nice thing for you to share on Stack Overflow, right? When you create a complete movie out of this, when you compress it, you'll be surprised. It may even be just 100 kilobytes after compression.
Oh, wow.
Because it's all text and so many repeating patterns. Yeah. And then the receiving end, they don't even have to uncompress it, because they can just uncompress to the console, not uncompress into a file. And the uncompression will basically just play out the movie, right? And it is so cool. So I will look forward to seeing this, and hopefully you can demo this too, later on. In fact, it'll motivate more students. I think if you do this, it'll motivate more students to work harder and complete all of these things in time. Right? So that they say, all right, I want to be doing cool stuff like Chris. He's coming back every week with all these really cool stuff. So it'll motivate more students to get their act together, okay? Because I see all of these guys, come once in a while. Okay, now they'll know. Okay, you're missing out on all the fun. All right, so that's all I had to say. If you have any questions, I'll answer them. Otherwise, I got 20 minutes before the next meeting. Maybe I'll just chill out for 20 minutes or so.
Okay, yeah. I guess just so to clarify, so we want our minimum length per line to be 50, right? And then if it's less, we would give
pick a number, okay? Pick a number yourself. Make a few frames of your own, okay? First, that's, I think, the best thing to do. Just make the frames first before you're writing the program. Make the frames, and as you're making the frames, you'll automatically get a feel for what's the line length to use for cutoff.
Right.
So you get a good idea for that. So don't say it's 50 and all, right? You got to determine the number. If less than 50, then you get, if less than 50, not syntax error. So
then it's a command, right?
If less, it's a comment. Yeah, it's a comment or a comment or a meta or a comment or an instruction. All right, or a frame gen instruction I think frame gen is one word. You use the word one word, right?
Yeah.
Frame gen instruction. So you're going to look at it. If it says frame, nothing else after that, it's a frame gen instruction with default parameters. Yes.
Yeah.
If it says frame with 2 parameters after that, you know what it is. It's a frame that has to repeat that many times. If it's neither of those and it's still less than 50, you're going to ignore it because it's a comment. Yeah.
Okay.
Cool. So those are the only 3 cases you can easily handle those, right? Check for a parameter. I don't know what that means. I don't know what the hash and all means. I can
Oh,
get
this
rid of
is
that.
like the number of parameters to determine
Oh, I
whether
see. I see.
we
Yeah.
do default
You can
value
always
or
email me, okay? As
yeah.
you're implementing this, if you're getting stuck, or even if you have questions saying, "Hey, I forgot what we talked about," just email me, okay? Even if I'm walking around, I can look at the email and reply to you. Yeah,
Okay.
because speech recognition works very nicely, so I can just talk and I reply to you. Right? If only has one word. Yeah, that's all. Any other questions? The only thing you are compensating for here is that in order to produce a sophisticated animations that you do with the cube, you need the sleep, really, I think.
Yeah.
Because each frame will be different from each other. I don't know. You would think about it.
Yeah, I can
Maybe even the
even
cube animation will eventually be possible using this, because maybe you have like 100 of those, 100 pictures that you rotate one after another to get the cube animation, and each one needs to be shown 50 times. So it'll be possible. But all of that can be later work. You can work all of that into the thing once you have the proof of concept.
All right, sounds good.
Awesome. All right. Thank you, Chris. And thank you
you.
for offering the award to Oliver. I did that. So
Oh,
I
yeah.
nominated Oliver.
Definitely.
We'll try and find out something interesting to at least if nothing, it'll just be in $50 on PayPal, okay? Which is exactly the same amount that Fotil allows. Gives out to the person at the ceremony. But take I don't know. I think getting the award at the ceremony is actually more of a pain. And hopefully Oliver won't have that, because I'll set the stage for him and say, well, it's a short introduction, so Oliver doesn't have to give a big spiel and all, so he can also say thank you or whatever he wants to say is fine. But I felt that many students were actually put on the spot, in the previous ones that I attended. So they get a thing and then they have to come and talk, and some students don't want to talk, and they're so it's a pain, I think, for some students. Anyway, and plus the adulation doesn't do any good to their learning, I think. Anyway, that's great. So thank you. I've made that known to Oliver, and
all right.
We'll
Sounds good.
All right. Okay. Bye.
Thank you, Professor.